as well as support packages and IDEs. Um, R is a programming language which has been used extensively, over time. And today again, it's another opportunity for us to learn about this programming language. And R does not stand on its own. It does not stand alone. R has some other assistance, or rather receive assistance from other neighboring friends, like IDEs. IDEs, we're going to be looking at it, will assist you to interact with R without stress. An example of IDE which we are going to install today is RStudio. R in itself is not user-friendly, if you permit me to use that word. R in itself, it's not user-friendly. R is more or less, it does work like in the DOS mode. But then it's important for us to look for a graphic user interface that can stand in between the users and R to be able to make R interesting and easy to interact with. So this is what dovetail into bringing in RStudio to interface with R, to be able to use it as to be able to make it as friendly as possible. So we are going to see more about that our work environment after we have learned about how to install and start necessary packages. And then we are going to also identify types of operators in R. And we're going to see that also with examples. Then we're going to use R tonight as calculator and as a tool to solve mathematical formula. Now, the first thing we have to do now is to download R and RStudio. Downloading R and RStudio. So R is provided for on a platform called rprojects.org. r-projects.org. That is the official page or official path to download our programming language. So this particular window has so many platforms where you can download R from. So when you click on this, it will launch you in an environment like this. The R project for statistical computing, into an environment where you can choose to download your R. R is also provided for in different, it has support for different platforms. It has support for Windows, it has support for Linux, it also has support for Mac. But I believe majority of us, the operating system that we are used to is Windows environment. So once you click on your download here, it will launch you into another page where you can decide to say, oh, fine, I want to download R for Linux. I want to download R for my Mac. I want to download R for Windows. So whichever one you pick here, ensure that is the relevant one you really want to pick. But most of the time, you download R for Windows. So as you click on this, this will take you to the executable file of R. The executable file is more or less like the setup file for R, which is it's easier to use. All you need to do is just double click and the programs will install itself into different parts of its choice. So just ensure that you do not tamper with the parts that is picking by itself by default. So double click on it and begin to unpack the program. Maybe you only need to click 1 or 2 clicks, next, and then the program is fully installed. So once your R is fully installed, that is a procedure. You must ensure that your R programming language itself is first installed. So once you are successful with the installation of R, the next thing is to go to installation of your RStudio. RStudio is also provided for here on this part. It's provided for rstudio.com. You find it on rstudio.com, products, RStudio. So once you click here, it will launch you into where you are going to get RStudio uploaded. So, I mean, downloaded rather. So once you download that as well again, the next thing for you is, don't forget, I said you are going to install this one over R. So you must ensure that the first thing you're going to do is to install your R programming language. Once that is done successfully, you're good to go. And then the next thing now is the second step is to download your RStudio. Your RStudio is an integrated development environment which will be found on this part, like I've said. Once you click here, rstudio.com/products/RStudio. Once you click here, it will take you to where you're going to download your RStudio. Once you fire your RStudio and it's fully installed, you don't even have to restart your system. The next thing you have to do is to launch your RStudio. But let's see a brief about RStudio. RStudio is an integrated development environment, IDE for R. It includes console, syntax and lighting editor that supports direct code execution. It also has tools for plotting, history debugging, and workspace management. We're going to see that after now. We're going to see the environment of R after now, which is here. And how do we get here? Like I said, I'm going to demonstrate it for you now from your end. I'm going to demonstrate it for you, which you can also repeat on your laptop. I'm going to press my window logo here. After pressing my window logo, I will just type RStudio. Once I type my RStudio, I just press enter. Or if you like, I don't know whether you look for the icon on your system to open your program. You just open it the way you normally open your Microsoft Word and all other packages that you are used to. So once you load that, it will just launch you into the RStudio environment. So that RStudio environment, it is the interface between you and hard programming language. So if you issue any R programming command here from this window, R will take that language, it will take that input from you and execute. So this is our environment. And from my PowerPoint, this is what I have. The RStudio environment is divided into 4 quadrants, 4 partitions, 4 different partitions. You will see one labeled quadrant 1. That is the first partition. You will see another one labeled quadrant 2. That is the second partition. You will see another one labeled quadrant 3. That is the third partition. And you see another one labeled quadrant 4. That is the fourth partition. And from these partitions, what do we do? What do we do around these partitions? Yes, in the first quadrant is where you key in your codes, where you create your files, where you type in your codes you intend to run. You can open as many pages as possible in this quadrant 1, or like your notepad. Normally in programming, most people prefer to write their notes using notepad. You can also write your codes in notepad. But then they have embedded that in RStudio. So you don't have to go to your notepad, a separate notepad open somewhere, and then copy it and then come and run it here. No. You have your notepad embedded in the first quadrant here of your RStudio. So once you finish with writing your program here, you can begin to do so many. So you can write as many pages here as possible. You can create one here. You can move here again to create another one. You can create another third page here. You can take as many pages as possible as you like on that page. At the same time, that is also a page where you can view your data, where you can view your tables. I'm going to say it as we go on. It's also a viewing page for your data. It's also a viewing page for your tables. So the second quadrant is like a global environment. a place where you can have access to your variables, to your variable names, to the properties of your variables, where you can see what your variable is made up of. Whether the variable you have created in your program, it's a numeric variable, whether it's a factor, or whether it's a string. This is where you can get all the properties of your variables at a glance. And then it also has a place where you can export. Let me go to the main thing where I can see is it also has a place where this is your history. Second quadrant is also here, where you can view your history of all the activities you have performed since you launched your R. You want to see some of the codes, some of the commands you have issued. The history will give you what you have done previously since you opened your computer or your R studio. So we also have a place where connection is a place where you connect to your database. Where you can connect to your databases from external databases or maybe within your local server as well. Then you also have a place where you can learn more about R, where you can learn more about RStudio. It's like the tutorial page that can give you more understanding about what you need to know. So now the third quadrant now, which is here, where you have this chart, is referred to as the third quadrant. So this place is the third quadrant where we have something like graphs. This is the place where your graph is plotted. The graph that you issue a command for, this is the place where you view the graph. In fact, it can do much more than that. So this is the third quadrant from our main window. The first point here, the first tab here, it has about 5 tabs. So the first tab here is for your files. The files on your computer, your filing system on your computer. Within here, you can see the filing system of all the things you have on your computer, the tree of your files on your computer. So from here, you can see it at a glance without having you to close the RStudio page and go to navigate to see where your files are, the structure of your file elsewhere. No. You can see the power of RStudio. RStudio has a lot of facilities that can make you to interact with your computer from this front end. So this is the plot where you plot your graphs, where your graphs that are plotted are presented to you. Then from this graph environment as well, you can also export, whether as PDF or you want to export as PDF, or you want to export as a PNG. You want to export as PNG. So sorry, from the other page they are telling me that they can't see the screen. So let me see. Show it. So that is that. So now let's move on. The first quadrant. This is where all the activities really take place. This is where you interact with your R. This is where you eat commands. This is why you tell your R what to do. This is where you feed in all the colors. Like the broad system environment, which is traditional to RStudio, to R itself. So this is where you issue the command. This is the fourth quadrant. So let's move on. So installation of packages. There are some additional packages that you need to install over the original packages that R will permit you to have access to. These packages give R more functionalities, which ordinarily may not be part of the package that came with it when it was computed. So it's more or less like add-on program that you add on to your environment. And we're also tolling the way or the road to manufacturing, if you like that, or to write code, to write packages that can be used globally by our communities. The people that write some of these packages are people like you, people like me, team that work together. to do one thing or the other. So today it is very easy for us now to now put some of those packages into our R environment, to just call them and use those packages, rather than us sitting down again to write codes to carry out that function for us. So that's why R is so flexible and it's so simple, because majority of the things you have to be racking your brain for by yourself all alone, some people had already worked on it. So all you need to do is to just call that program, call that function for wherever it is loaded, and you just use. Now, what are packages? Packages are shareable collections of code, data, and documentation packages that are essentially extensions or add-ons to the R program that can be installed within R environment. So one of the most popular collection of R packages known in R is called tidyverse. Tidyverse is a collection of R packages designed for working with data. So tidyverse is like a suite of program that consists of all this list. So readr is an example of a subset of tidyverse, which is most times used for data import. So it is most times used for data import. And ggplot2 is usually used for data visualization. The player is for data manipulation, and a host of others like that. So you call them as at the time that you need them. But before you can have access to it, you must install. You have to install it in R. So I'm going to show us how to install these packages. You know, like I said, it is possible for you to install this tidyverse only once. And as you install this one alone, this tidyverse alone, it will automatically install all the dependent packages, all of these ones for you, which is what we're going to see now. So the code, there are many ways to install packages in your RStudio. One of the ways which is very friendly is to use the graphic user interface, the graphic user environment in your R, which I'm going to show you. You can either come here and say packages. Once you click on packages here, there will be a drop-down menu showing you all the packages already resident in R, that are present in R. So it's possible for you to update the existing packages from here by clicking here. It is also possible for you to install new packages here. So once you click install here, this menu will fly out. So it's possible here, fly out. So all you need to do here is to just put tidyverse. That is the name of the package you want to install. So once you click here and you say install, all you need to do is just sit back and watch your program being installed, the package being installed, and it will install itself in an appropriate path. All you need to do is just sit back and watch it install. So once you see this button here, you can see now the progress. You can see the progress of the installation. It's going on. You can apparently stop the installation from here, but you don't want to stop that. So it's successfully installed, and your prompt is already blinking, waiting for next instruction. At the same time, it's also possible for you to be installing these packages one by one. But if you can install it at a go, why do you want to be doing it one by one? Why do you want to make it manual? It's also possible for you to say, oh, I want to install readr alone separately. So all you need to do is come here as well, click on install, and just click your readr. readr. You just say install. But I don't want to use this place to install. I want to go back to another place to look for how to invoke that. You can also come in here, in your console here, and type install dot packages, and then device. And just press the enter. And the next thing you will see is that it will begin to install, but you must ensure that you are connected to the internet. You must be connected to the internet because it's going to fetch the files online. It's going to fetch the files online. So it is successfully installed. So those are the two major ways by which you can install your packages. You can come in here, type it. You can also come in here if you like. Don't forget, look at the way I've written it. Install the packages, then you put it inside inverted comma, and then they must be inside brackets. You find out that I did not put the tidy verse in any inverted comma here. I just type the name as it is here. But by the time you want to execute it within your console, in your fourth quadrant, you need to put it in double quotes at both ends and then inside your bracket. So let's move on. So we're done with that. So once you are done with that, you cannot still use it unless you invoke it. You cannot still use that package unless you call it up to come up for you to be able to use it. So what you need to do is to bring it up, to load into the memory of RStudio, into the computer, you will say library tidyverse. Tidyverse is the name of that package you want to use. So you will just type within here again, library, inside that, tidyverse. And you see that it must be inside bracket, and just press enter. There you go. Library tidyverse. So it's trying to load it into the memory of the computer. Once no error is generated, you can see that. You can see what you have on the screen. So all those other programs are loaded. You can see ggplot is already loaded, table is loaded, tidyr is loaded, read is loaded, string is loaded, and every other one. They're all loaded. So as it is now, you can begin to use. The same thing goes for any other package you can think of that you want to use. That is the way to get them installed. And after the installation of that package, the next thing is you must ensure that you load it into the memory of the computer using library and the name of the package. So now the second part is the types of operators in R.
Okay. You still get tablet with this.
Operators Sorry, the network went off, but I think we're back. We are fully back. Okay, so that's fine. Okay, so I was talking about operators. This is very important. So the first one we're going to experiment with now is our arithmetic operators. I'm sure you can't see my screen, so I may have to share my screen. Okay, so I was talking about arithmetic operators. We have the addition, the subtraction, multiplication, division, exponents, modulus, integer, and so on and so forth. So if we look at the first one, the addition, it is like our normal addition that we are familiar with, plus. Subtraction is our minus, like that we're also familiar with. So it's the same thing. The language is very universal. And the other one here is multiplication, which is our star in this case. It is not x. In R, you use a star to represent multiplication. And front slash is the division. Why this correct is exponent. That is, a number raised to power another. Or in the alternative, you can also use double star to represent exponent. You can use double star to represent exponents in R. And then modulus and integer. So we're going to experiment now. So if you look at this here, you can see x. Look at my cursor. X is less than x, something like less than, okay, something like less than dash, you know, and 5. So what this is saying is put this 5. Please throw this arrow into x. This is what it means. Put this 5 into this container called S. What that is saying is save this 5 into x. The same thing goes for this y. Put 16 inside y for me, so that at any point in time I can call for it to do whatever operation I want to perform. So the first thing you have done is you have stored. If you type it this way, you know, this is like the less than sign and minus that will write that way together. So the next thing here is you want to sum it. You want to sum. How do you do that? You want to sum together. How do you do that? You just say x plus y. That is the only thing you need to type. Once you type x plus y, you press enter. The response you are going to get is 21. So I'm going to do that now. I'm going to go to our R environment and get this done. Don't forget, the first thing you have to do is store your 5 inside x, and then come back again, store your 16 inside y. So I'm going to go to RStudio to do that, and let's see what we're going to have. This is my RStudio here. I want to put inside x 5 inside x, which is what I have done. Y again. I am going to, let me see if I can maximize this guy. Okay, oh, it's still not doing what I want. Okay, so I'm going to put 16 inside my y and I press enter. No. See? And I press it. So I have my x and y inside my box already stored. Now I want to add them, x plus y. Once I press that, I press enter, I get my answer, 21. I want to subtract x minus y. I press enter, I get minus 11. But let me do y minus x, because 16 is greater than x. Let's see what we're going to get. I get my answer, plus 11. Let's go back again to our PowerPoint and see what other combination we have to do. You can see. Let us do x star y, which is multiply x and y together. What will be our answer? I flip to that again. I say x star y. I press enter. I get my 80. Why don't we do a division? X divided by y. What do we have? 0.3125. So this is what you have to do. This is how to use your R as your calculator. You can think of anything. You can say, okay, you can even say x. Okay, I think do we have s squared here somewhere? We don't have s squared here. We can even say s squared, which is x. Is it that x times x? That's like x multiplied by itself. Then y squared, y times y. Sorry, y times y. There you answer 496. In the alternative, you can say x star 2. That is x raised to power 2. What do we have? Sorry. Oh, now x how is case sensitive? So if you have defined your variable as small x and you are now calling it up as capital X, it will tell you I cannot find that variable. That's what has happened to me here. So it's just our small x that I have to raise to the power of 2. Like I said, you can use star 2 get your answer 25. Or in the alternative, our x caret 2. Where is caret? I think it's over 6. Caret is over 6. Shift 6 2, and you press your enter, you get the same thing. So this is as simple as ABC. So let me quickly move on because of our time to relational operations. Relational operations has to do with, is this one greater than this one, or this one is less than this one? So you can see the less than sign here. This is the less than sign that is used in R environment. This is the greater than sign that is also used in R environment. This is less than or equal to, this weight is written in R. This is greater than or equal to, this is the way it is written in R. So now this is not equal to, this is the way it is written in R. Like not equal to, this is the way it is written in R. So let's do experiment again. We have already assigned our x to be 5 and our y to be 16. So we now want to check logical thinking, logical check to ensure whether our x is less than y. If this is true, it will tell us it is true. And if it is not true, if it is otherwise, it will tell us it's not, it is false. So if you look at our figure here, our x is ordinarily less than y. Our x is 16 and our y, our x is 5 and our y is 16. So when you ask computer, tell me, tell me is x less than y, what do we have? It's true, that's correct, because our x, which is 5, is less than 16. So let's check again. Is our y less than x? No, that's false. Our x is not less than y. Our y is not less than x, so that is giving us false. So these are logical relational operations. These are the ways it is. So I'm going to go to the next one. The same thing goes for the remaining as it is. These are used for Boolean like logical operators. You know, the logical not is as written. The logical and is double ampersand, and so on. The logical or is like 2 pipes written together. 2 pipes written together. So if you look at this one now, I'm going to come back to this later, not in this class today, and later as we go on, because we have not done how to all these column. We have not done it. I don't want to go into it now, but this is the way it is used. So but let's go to the last one because of our time. Assignment operators. We have experimented with assignment operators the other time. It's used to assign values to variables. Like I have said, I have used x now. I have assigned 5 into x. So this particular sign, this less than sign and minus, is referred to as the assignment sign. So I've assigned 5 into a container called S. So when you, like we have done, we have seen that experiment. And then you can also, it can be from whether to the left or to the right. If you look at this one as well, you can also use equal to say that let my x be equal to 9. Just write equal to as well. The R will also take your x to be 9 as it is. So you can also say, okay, write it this way, put 10 inside the, using the right assignment statement now, the right assignment sign, put 10 into a container called X. So that's what we have. So now from our hand, let us use this as calculator, just like we have done. As a console within RStudio, you can carry out some calculations, but before then, it's important for us to identify the operators just like what we have done. So you have store 25 inside X, put 31 inside Y, put 10 inside Z. So I'm going to do it from my end as well, and then we can resolve this equation. This equation is saying that add X plus Y divided by Z. I don't know the answer from my head, given what we have previously. At the same time, can you raise Z to the power of 2 and then divide it by 20? So let's see. We're going to go to RStudio and then assign our X to be 25. Where is R? Okay. Close that. I'm trying to bring it up again. Trying to bring it up again. So while R is loading again, I don't know why it crashed. I'm going to bring it up again. It's coming up. Don't worry. Not to worry. Not to worry. It's coming up. Coming up in 10 seconds. So yes, it's there. So we're going to put, what we intend to do now is put our X. Put what do we put inside X? Don't forget, like I said, R is case sensitive. We want to use capital X now because that is what we are given. To store our value 25. Value 25. Put 25 inside X. If you like, you can do it this way. Then we're going to put our Y, which is our Y. What? Y is well, I think the network is back. It rained yesterday actually, so and when it rains, the network is always having problem. But thank God it's not that it's raining today, but it rained yesterday, and I think maybe they are still trying to take care of the equipment. But I think we're back. We're almost done. We'll be done. We should be done in about 10 minutes. So the next thing now is talking about our, just to talk about our, the assignments for against next week. So the assignment against next week is the only thing I want to show us now, which is here. So we have succeeded in doing this. We have succeeded in doing this successfully. So the next thing now is to use R to solve mathematical formulae. To use R to solve mathematical formula. So solve the following quadratic equation. How do you solve the following quadratic equation? Like we all know, don't forget mathematics equation. There are a number of formulas which you can use, but I think the formula I want to advise or I'm recommending that we should use here, it's our almighty formula. The formula we're going to use is our almighty formula, which is usually known as the quadratic formula, which is minus b plus or minus squared b squared minus 4ac all over 2a. So that is what we're going to use to solve this equation. So that's what we're going to use to solve this equation. So and how do you do it? I'm going to give you a you're not going to do this like we have done using it for arithmetic calculations. No. You are going to go to your my screen is not coming up again. Okay, you are going to go to your calculate. You are going to bring out your formula like minus b plus or minus squared b squared minus 4ac all over 2a. You can see there that we have plus or minus. That plus or minus means you have to get two answers. Normally, like we used to do, two answers. So you have to treat it one by one. You have to start with minus b plus square root b squared all over 2a. So you have to put that in an expression on a straight line. And then you begin to substitute those variables. And if you look at my screen here, the coefficient of s squared here is what? The coefficient of s squared here is this first equation is 1, if you still remember. So that is our A. The coefficient of our x here, it's 5. Which represents our B in the formula. So this one minus 2a as it is, it's just our C. This is our C. Minus 2. You will now substitute minus 2 into C. And that is what we have. And you just fire it and you get your answer. So you now go back again to treat the negative part, which is minus B minus, we used to have plus or minus. So you now pick the minus part. Minus b minus minus b plus or minus squared b squared minus 4ac over 2a. So pick minus b minus square root b squared all over 2a. So once you are done with that, you move to the next equation. And if you look at the second equation here, the second question here, this is presenting to us that we have the coefficient of s squared here. In this case, is 2. So this 2 will represent your A. And you move again here, the coefficient of x here is 3, which means your B here will represent 3. So you will substitute 3 into your equation, which is your almighty formula, which we have started, the quadratic formula. And your C in this case is minus 5. So this is the assignment you have to submit in 1 week on the platform. So if you're already connected with us on the Google platform, you will have the opportunity to be able to submit it. But if you're not connected on the platform, you are just an observer, there's no way we can get your your assignment submitted. So I'm going to give this page to you guys now in case you have one or two questions, so that in next 5 minutes we can
I have
round up
questions.
for the day. So
I have some questions.
over to you. Okay.
I have some questions.
Yes, Madam, I think. Can you go on, please?
Okay. Yes. Number one question I want to ask: when you are teaching us about the arithmetic operations, I noticed there is one in between a bracket. It's always showing one. You bracket one. So you did not explain that the function of that one, like x,
Which one is that?
one into bracket y, something like that. When you are teaching us under the arithmetic subtractions and so on, the equations by the right hand side, there is always
Yes.
one by the bracket. You didn't mention it.
Oh, that's the location. Thank you. Yes, I have seen it. I think it is telling us that because the answer we are getting at the end of the day is just one answer. It is not two. You know, do you know matrices?
Okay.
If you remember matrices 2 by 2 has 4 locations. Sure, you understand.
Okay.
Matrices, just like we have
Okay.
matrices 2 by 3 has 6 locations. So this one is just presenting us only
Okay.
one location. The answer we're having is only one answer. So it is stored in one location. So that one is not the answer. That one is just telling us that the answer we're having, it is stored in one location. That is just it.
Location. Then the second question, sir.
Yes.
The assignment you gave to us to do, I think you should help us to do one so that we can follow up on the example.
What's the question again? Oh, the assignment.
The assignment you gave to us.
No,
Yes.
once I do one for you, I have done everything. So I have, because I mean, you are going to romance it for 1 week. So the way that I've explained is enough for you to understand what to do. So by the time you spend 1 hour with it maximum, you should be able to understand it. So I think that's fine. Mr. Mukala, let's listen to you too.
Thank you very much, sir, for the explanation. I just installed the RStudio now, and it was okay, except that unlike yours, when it displays 4 quadrants, but mine is just displaying just 3 quadrants. And I as well tried to install the package, the tidal verse.
Okay.
Of course, it was loading several. I'm sure it was
Packages.
installing several different
Yes.
packages inside it.
Yes.
But
Yes,
the
that's true.
last one that came up shows error in install
Are you sure? Are you
install
sure?
dot packages. Then it wrote cannot open the connection.
Well, it could be the connection to the internet at that point when it was about to load that. That's what I can readily think
But
about.
because it has installed a lot of packages, but I'm like the 2 last ones came with red
Flag.
letters. Yeah. So I'm
So
saying could not
what you can
find
do,
function learn. Okay.
what you can do in the alternative, just try to install those ones separately and see what you get again. The remaining ones are already
Okay.
installed. So those ones that are proving stubborn, install them separately.
Okay.
And
Okay.
so you should be
Then
fine.
the first question.
Okay.
The first question.
Yes, yes. What's the first question?
The I'm supposed to have 4 quadrants, but I'm having just 3 quadrants.
Oh, it should be 4. Maybe you have mistakenly mistakenly pressed minimize.
Minimize.
So
Where
if
is
you have
that located?
mistakenly okay, if let me show you, let me share my screen again.
Okay.
If you mistakenly press minimize, it might take it off. So we have to bring it back. You can see something like you can see I have 3 quadrants now. Can you see my screen? Have you seen my screen?
Not yet.
It's there. I can see it from my monitor.
Yep. Yes.
Now.
Yeah, I
So
can
you can see,
see
is that
three
is that is that
quadrants.
not 3 screen that I have? So you come here and click this.
Yeah.
Once you click that, it should split your screen into 4.
Okay.
Yeah, that's the problem.
Oh yeah, that's true. That's correct, sir.
Yeah. Okay, that's fine.
Yeah, that's
So
Okay.
that's fine. So
thank you.
I have
any
a
other
question.
person?
Yes, I have a
All right.
question.
Okay,
Yeah.
can you go?
Yes, I missed the part where you install the R.
Okay.
Because when I tried to earlier in the day, I actually scanned through it, and I saw I saw that the arrow is like it's located by country. So I wasn't sure
Yes, you
which
know,
one
you
to
can pick
select.
any one of your choice. Any one will work.
Okay, okay. All right, thank you.
Okay, you're welcome. Please, that person should mute his mic. Mrs. Titilayo. Oh no, if please mute your mic. We can hear the children. Mute your mic.
I'm not the one.
But try mute your mic because it's only your screen I can see that is not muted here. So, okay, any other question? Somebody is trying to say that I should show the screen. I would. It. I will post it. I will post it. It's already posted apparently. This PowerPoint. This PowerPoint. You will have access to it. So you will see it there. And we'll be able to click and then use it. Yes, I think somebody was raising up his hand. Can we take your
And
question?
Mr. Samonjola is raising.
Okay.
I'm just. Hello, good evening.
Yeah, good evening. Let's hear you.
I've been wanting to be let in since about 7 o'clock, but maybe the network. I don't know what happened. So I'm just coming in now. I didn't even know what to what to discuss,
Anyway,
the assignment and everything.
It's okay. You would see by tomorrow. The video should be ready.
Okay.
So the video will be posted on the classroom page.
Okay.
And you can follow it. It's just like even if you have missed the class, you can still follow it. It's the same thing.
Okay.
That's why I always encourage us to come early.
I've been trying it since
So
about
that
5 minutes. 5 minutes to 7 o'clock, but it was
yeah,
just
sorry
not
about that.
breaking.
Sorry about that. Okay, that's fine. Any other one before we close for the day?